Good day, everyone. The topic that I will be discussing today is network access. Now, there are seven layers in the open systems interconnection model: the physical, data link, network, transport, session, presentation, and the application layer, as been discussed in the previous lesson. Now, these layers are important because it defines how computers connect with each other and transport data over the network effectively. As simplified. On this topic, we'll be discussing the two layers used for connecting computers: the physical and the data link layer. The physical layer defines the relationship between a device and a transmission medium, such as a copper or optical cable. Now, this includes the layout of pins, voltages, cable specifications, hubs, repeaters, network adapters, host, bus adapters, and more. Okay, we'll be discussing those terms as we go on through this lesson or this topic. Now, let us see the different physical media used in the physical layer. One of the most important and commonly used component when connecting computers is the network interface card or NIC. Okay? So it is a component that provides networking capabilities for a computer. It may enable a wired connection such as Ethernet or a wireless connection such as Wi-Fi to a local area network. So this network interface card can be seen when you open a CPU. Okay, so it is plugged on a slot on the motherboard, and you can also find the network interface card at the back of the CPU. This is where you plug in your cables, your network cables. Next is the term router. Okay, so what is a router? So a router is a hardware device designed to receive, okay, analyze, and move incoming packets to another network. It may also be used to convert the packets to another network interface, drop them, and perform other actions relating to a network. So this is an example of a Cisco router. Okay? Now, if you have a wireless or an internet at your house, uh, most probably you have seen a router already. So because what you use for your Wi-Fi connections at your home is uses a router. Next, let's discuss, okay, what is a copper media. Okay, so the most commonly used media for data communications is cabling. Okay, that uses copper wires to signal data and control bits between network devices. Now, cabling used for data communications usually consists of a series of individual copper wires, okay, that form circuits dedicated to specific signaling purposes. Okay, there are three main types. Let me see. Three main types of a copper media, okay, used for networking. We have the unshielded twisted pair or UTP cable, the shielded twisted pair or the STP cable, and the coaxial cable. So these are how those cables look like. Okay, so you have the unshielded twisted pair, the shielded, and the coaxial cable. So let us discuss them one by one. But before we discuss this, by the way, let us talk about the advantages and disadvantages of using copper media, okay, in networking. First is advantages. Okay? So, inexpensive. Okay? So, buying cables, okay, the Ethernet cables is very inexpensive. Okay? Uh, the price range will depend most probably where you will buy the Ethernet cable. Okay? Low resistance to electrical signals. Okay? Easy to install. All you need to do is to plug it. Okay, then supports power over Ethernet or the PO, and it is more flexible. Okay, disadvantages of using media, copper media is, okay, or electronic magnetic interference, or the EMI, the radio frequency interference. Okay, they are very prone for the from these interferences. Okay, crosstalk. Okay, breaks easily. Okay. Support maximum up to 100 meters. So there is a distance, okay, wherein you can only use wired networks. Okay. So we'll be discussing that more on as we go on through this topic. Okay, so let us now go back to the different types of media. Okay, first we have the coaxial cable. Okay. So what is a coaxial cable? So a coaxial cable has a single conductor that runs through the center. Okay. Let me zoom into the picture so you can see it. Okay. As you can see, okay, the single conductor, okay, the gold, color gold wire, okay, at the middle of the cable, okay, at the center of the cable, okay, is encased by but insulated from, okay, the other shield. Okay, the copper media type chosen a specific, okay, by the physical layer standards required to link the data layer of two or more network devices. Okay. So you might have seen a coaxial cable, like if you have a subs or you have a subscription on a cable channel, for a cable channel, the cable that they used at for their digital box, for the box that they are using, is a coaxial cable. Okay, next. Okay, we have the unshielded twisted pair. Okay, or the UTP cable. Okay, this is one of the least expensive wires and works for basic needs of phone systems. So it is one of the most commonly installed residential industries. Okay, so each wire in the UTP cable model has four parts. Okay, we have the conductor and the insulator are parts of the wire itself. Okay, the third part is the twisted units. As you can see, the cables are twisted. There. The twisted units. Okay, the twisted units will have two wires. Okay, each one will have a conductor and an insulator. Okay, the sheet covers the set of twisted wires, keeping the whole unit from cuts, scrapes, burns, and many more. Because UTP cables are very sensitive. Okay, so for example, if you step on a UTP cable, it is very prone to break or to be damaged. The wires are prone to be damaged. That is why it uses a wire for each wire. Okay, the conductor and the insulators. Next, we have the shielded twisted pair, or the STP. Okay, the STP, okay, the outer insulating jacket contains an inner braided copper mesh to shield the pairs of twisted cables, which themselves are wrapped in foils. So as you can see in this cables, okay, this is the STP looks like the UTP cable. The only difference is the foil that you can see here. So the STP does not have a foil, unlike the STP cable that you can see in this picture. That basically they have the same colors and the same number of wires, okay, which is the insulators and the conductors. Okay, now next is the RJ45. Okay, the RJ45 is a type of connector commonly used for Ethernet network. It looks similar to a telephone jack but is slightly wider or bigger. Since Ethernet cables have an RJ45 connector on each end, Ethernet cables are sometimes also called RJ45 cables. So this, once you connect, as you have see as you can see in this picture, the second picture, the end of the UTP or the STP cable is the RJ45. Now the RJ45 is where you connect the cables, okay, either straight through workstation or workstation to a router, okay, in order for it to have a connection, okay. So sometimes if you connect a computer to a router, okay, the IP addresses, etc., the needed protocols needed are already set by the router. Okay, not unless if you will connect a computer from another computer using an internet cable, you have to set the IP addresses in order for the two computers to communicate with each other. Okay, now in order for you to connect, okay, the UTP cable or the STP cable to an RJ45 connector, you will be using a crimping tool. Okay, now a crimping tool is a device used to conjoin two pieces of metal by deforming one or both of them to hold each other. The result of the tool's work is called crimp. Okay, an example of crimping is affixing a connector to the end of a cable. For instance, network cables and phone cables are created using a crimping tool, okay, as shown in this example. To join RJ45, which is used for Ethernet, and RJ11, which is what you use for telephone wires, connectors for both ends of calls or Cat5 cable. So Cat5 cable is the type of UTP cable. Okay, so it is thicker. The Cat5, it's more thicker and it's more harder to bend if you will use the Cat5 cable of a UTP cable. Okay, to create an Ethernet cable, you will need a UTP or an STP cable, an RJ45, and a crimping tool. Okay, there are two kinds of Ethernet cables, okay, that you can make. Straight through or crossover. Okay, so let's discuss them one by one. Okay, first we go to straight through. Okay, basically we are talking about the arrangement. Okay, how the cables are arranged. Okay, so when you place these cables or these wires inside the RJ45, okay, the colors should be followed as illustrated here. Okay, so Ethernet cables are the standard cable used for almost all purposes and are often called patch cables. It is highly recommended that you duplicate the color order as shown on the left. Okay, and note how the green pairs is not side by side as are all the other pairs. Okay, this configuration allows for longer wire runs. Okay, so always remember the arrangement of the wires. Okay, so when you put it inside the RJ45, okay, because if you will not follow the color coding when you placed it on the RJ45, okay, there will be a big problem connecting your computer from the network. Okay, so once these cables are placed or pushed inside the RJ45, then you will be using the crimping tool to crimp the cables in the RJ45 together. Second, we have, okay, the crossover cables. Okay? So the crossover cables or the crossover, okay, the purpose of a crossover Ethernet cable is to directly connect one computer to another computer or device without going through a router, switch, or hub. So it depends. So if you will connect computers using a router, you make use of straight through. If you are connecting or you will be connecting computers directly from each other, you will be using the crossover cables. Okay, so the type of connection will depend on the kind of cables that you will be using. Next, okay, another cable used for networking is the fiber optics. So this is a more advanced type of network cable. So it offers significantly improved performance in terms of bandwidth. Okay, and data carrying than traditional metal conductor versions. By the way, yeah, don't forget bandwidth means the amount of data that can be transferred, okay, over the internet. Okay, that is what we call the bandwidth. Okay, now optical fiber cable is used to transfer information via pulses of light, okay, which passes along one or more, indeed, anything up to a couple of hundreds in sometimes cases. Transparent glass or plastic pipes. Okay, so as you can see in this illustration, you the core is made up of plastic pipes. Okay, or glass transparents. So each of these strands is little wider than an average hair. Okay. And will normally be surrounded by a further layer of cladding, also in glass or plastic, but constructed at a different density to the main inner strand. Okay, so that is how or what a fiber optic cable looks like. Okay, now let's go to wireless media. So this is what we are commonly using, okay, nowadays. Okay, so the wireless media carry electromagnetic signals that represent the binary digits of data communications using radio or microwave frequencies. As a network medium, wireless is not restricted to conductors or pathways like when you're using cables or fiber optics. Okay? So as our copper and fiber media, okay, wireless media provides the greatest mobility options of all media as you experience when you are connected over a Wi-Fi. Okay, so the three pictures shown here are examples of a wireless media. So you may make use of Wi-Fi, a Bluetooth, or a WiMAX. So these three are examples of a wireless media. Okay, now we go to our last topic, which is the data link layer. Okay, the data link layer performs three key functions. Okay, remember this: media access control, error detection and correction, and message delineation, which means delineation means identifying the start and end of the message. Okay, so each network adapter also has a unique hardware data link layer address. So there are multiple addresses. Okay, because these addresses are set in hardware, each data link layer address is permanent. Okay, some of the addresses here you might have heard. Okay. So the data link layer has two sublayers. Okay. So we have the logical link control, or the LLC, and the media access control, or the MAC. You might have heard of this, the MAC address. Okay, so each devices, even your cell phones, okay, even your tablets, even your cell phone, even your whatever device you are using, when you are connecting to a network, each of them has a MAC address. Okay? The LLC communicates with the network layer. It identifies which network layer protocol is being used for the frame, while the MAC defines the media access process performed by the hardware. So the MAC provides data link layer addressing and access to various network technologies. And that ends this topic. Thank you for listening.